Welcome friends and welcome back to Numericals Studio. Today we have started this topic by considering a very interesting scenario from our daily life. Have you ever seen during pursuit or chase, we always follow the target like a missile tracking a boat? You can see there is a missile that is tracking a boat. So as the boat changes its path, missile recourse its path accordingly and try to follow the target. So this kind of scenarios is very much important, and what kind of physics concept is underlying it. So basically, we'll be trying to understand all those things in this particular video. So in this series, we have taken a similar problem from book Irodov to understand the concept and understand the logic, that what logic we should apply to solve this kind of problem. This problem can be extended to different scenarios. So once you understand the basic concept, it will be very easy for you to understand and apply the concept in all the pursuit related problem or chase related problem. Pursuit and chase related problems are also called a rotundum curve. Okay, so just stay tuned and we'll be back with a bang. So let's jump into the problem straight away. The problem states that a dog moves uniformly with a velocity v, so that the vector v is continually aimed at cat, which in turn to moves rectilinearly and uniformly with a velocity u. And it is given that the velocity of cat is lesser than the velocity of dog. At initial moment, the velocity of cat and dog are perpendicular to each other, velocity vectors. Okay, you can see here, its velocity vectors are perpendicular to each other. So at some point, the cat and dog converges, and initial distance between both this cat and dog are L. So we need to find out at what point dog will basically catch the cat. Okay. So as I just told you that, pursuit problem, it is very much important that you understand that in order to catch something, the person who is following the target need to have greater velocity. That's what our common sense says. Okay. So let's try to understand this thing. Now, suppose this is the point P at particular time T, and this is the point M, the position of cat at particular time T. And distance between these 2 points is R. Okay. So we know that this R will be continuously decreasing with each passing time. Suppose the velocity vector of dog is making an angle theta. It will be different after some time. So this theta is also time dependent, right? This theta is also a function of time. So theta will be continuously changing. Now let us try to see that what will be the relative velocity of dog with respect to cat. If I just draw two diagrams of frame, cat and ground, and I just observe the dog, then in that case, the position of dog with respect to ground can be written as position of dog with respect to cat plus position of cat with respect to ground. So based on this, we can just easily calculate VDC can be VDG minus VCG, and which is why we have written this. Now, in order to apply the concept of relative velocity, we understand that velocity comes with a direction. So if the velocity vector of this cat is in this direction V, then we have to take the direction of velocity of the cat in this direction only. Now, if this angle is theta, then and velocity of cat is in this direction u. Okay, if velocity of cat in this direction u, and if this is theta, then we can write this will be an u cos theta. So we can write VDC can be v minus u cos theta. So ideally, this is nothing but the velocity of approach. And what do you mean by the velocity of approach? The velocity of approach is nothing but the rate of change of distance, decreasing in distance between the two objects in concern. Okay. So this can be written as ds by dt, because as the distance between the cat and dog is continuously decreasing. So minus ds by dt can be written as v minus u cos theta. So initial distance between the cat and dog was L. So I can integrate from L to 0, because finally when at the time of convergence, there will be no distance between the cat and dog, and initial distance was L. So I can write, and suppose T is the entire time taken by a dog to catch the cat. Okay. Now we all know that in all the catching problem, it is important, but at the time of catching, both the position, both the objects should have covered the similar position, okay, similar distance kind of thing. So if two particles are chasing, suppose, and this is the point of meeting, then this particle should reach to this point and this particle should reach to this point at the time of catching should be same, right, with respect to an origin. So now cat is moving in the horizontal direction in this direction, and dog is moving having an y and x axis both, okay, y, it has got the y axis and x axis both, okay. So we understand that if we just try to resolve the velocity of dog in the direction of cat, so I can write v can be written as v cos theta in the direction of cat. So I can write v cos theta dt, the horizontal distance traveled by the dog in the horizontal direction, can be written as ut. So if I just eliminate this cos theta dt, which is already in variable in nature, so I can write cos theta dt can be as ut by v. Now I'm just going to put this ut by v here in this particular equation, where I need to get the value of cos theta dt, because theta, as I've already told you, theta is also changing. So we need to replace it with some value that is already known to us. So L can be written as Vt minus u square t by v. So with just a slight calculation, we can write that time of convergence will be Lv by v square minus u square. You just simply put v equal to u. In that case, you will be getting t equal to infinity. And if you just put that v is less than u, then you will get the t is less than 0. Okay, in both the cases, dog will never be able to catch the cat. So it is very much important for any catching problem that the object that is following the target should have the higher velocity, should have the higher magnitude of velocity. Okay, so I hope with this we have cleared the concept of pursuit. You should always understand that velocity approach is nothing but defined as the rate of change of separation between two body decreases. I will be bringing up some more problems based on this concept, but this is a very starting problem, and this is definitely going to help you to understand and apply the logic in other problems, in other scenarios as well. Wherever you will find this kind of things, there is a pursuit or chase is involved, you apply this concept and you will be just solving the problem with flying colors. Okay, friends. So thank you for your time and have a great day.